learning goals. Welcome to this learning session on frequency tables, calculating averages. In this course, we shall address Introduction to frequency tables and averages, identifying mode and median, calculating mean for discrete data, mean for grouped data, calculation and estimation. Practice problem, estimating reaction times. There will be a quiz at the end to test your knowledge.
Introduction to frequency tables and averages. Frequency tables are powerful tools used to organize raw data, making it easier to understand and analyze. They display the number of times each value or range of values appears in a dataset. This structured presentation is crucial for quickly identifying patterns and trends within large sets of information. Calculating averages from these tables allows us to summarize the central tendency of the data. The three main types of averages, mode, median, and mean, each provide a unique perspective on the typical value within a dataset. Understanding these different measures helps in making informed decisions and drawing accurate conclusions from data. Identifying the mode in frequency tables. The mode is the value that appears most frequently in a dataset. In a frequency table, identifying the mode is straightforward. It is simply the data value corresponding to the highest frequency. This measure is particularly useful for categorical data or when looking for the most common occurrence. For example, if a survey on favorite colors shows blue with the highest frequency, then blue is the mode. A dataset can have one mode, unimodal, two modes, bimodal or more, multimodal, or even no mode if all values appear with the same frequency. Determining the median from frequency tables. The median is the middle value in an ordered dataset. To find the median from a frequency table, first calculate the total frequency, n. The position of the median is found using the formula n plus 1 or 2. Once the position is known, locate the data value that corresponds to this position by cumulatively adding frequencies. For instance, if n is 37, the median position is 37 plus 1 molo 2 19th value. By summing frequencies, we find which data value encompasses the 19th item. This method ensures that the median accurately represents the central point of the data, unaffected by extreme outliers. Calculating mean for discrete frequency data. The mean is the arithmetic average, calculated by summing all values and dividing by the total number of values. For a frequency table with discrete data, we multiply each data value x by its frequency f to get f's x. These products are then summed to find the total sum of all data values. The formula for the mean is the sum of fx divided by the total frequency, cell f. This method efficiently accounts for each occurrence of a data value without listing every single item individually. For example, if 18 students have one pet, it's 18 to 1, rather than adding 1 18 times. When working with grouped data, we estimate the mean using midpoints. This allows us to apply a similar mean calculation method as with individual data values. When data is presented in grouped frequency tables, we don't have exact individual data values. To estimate the mean, we use the midpoint of each class interval as a representative value for all data within that group. This assumption allows us to apply a similar mean calculation method. The midpoint x for each group is calculated by adding the lower and upper bounds of the interval and dividing by 2. For example, for the interval 0 t len 20, the midpoint is 0 plus 20 2 equals 10. This midpoint is then multiplied by the frequency f of its group. Calculating mean for grouped frequency data. After determining the midpoint x for each class interval, the process for estimating the mean mirrors that of discrete data. We create a new column for fcax x, where f is the frequency and x is the midpoint of each group. These products are then summed. The estimated mean is found by dividing the total sum of f times x by the total frequency, f. For instance, if the total sum of f times fx is 15 and the total frequency is 150, the estimated mean is 315 150 equals 22.1 minutes. This provides a reasonable approximation of the average for grouped data. Why grouped data mean is an estimate. It is crucial to understand that the mean calculated from a grouped frequency table is always an estimate, not an exact value. This is because we assume all data points within a given class interval are concentrated at its midpoint. In reality, the actual data points are distributed throughout the interval. For example, in the 0t20 interval, we use 10 as the midpoint, but the actual travel times could be 1, 5, 15, or 19 minutes. Since we do not know the exact individual values, our calculation provides an approximation. This distinction is vital for accurate data interpretation and reporting. Practice problem: estimating reaction times. Let's apply what we've learned to a new problem. Emma recorded reaction times for her class, presented in a grouped frequency table. Your task is to work out an estimate for the mean reaction time using the midpoint method. First, determine the midpoint for each reaction time interval. Next, multiply each midpoint by its corresponding frequency. Finally, sum these products and divide by the total frequency to find the estimated mean.
Summary. Well done. You have completed the course Frequency Tables, Calculating Averages. You should now be familiar with Introduction to Frequency Tables and Averages, Identifying Mode and Median, Calculating Mean for Discrete Data, Mean for Grouped Data, Calculation and Estimation, Practice Problem, Estimating Reaction Times. Should you need to revisit any of the topics in this course, please use the menu at the bottom of the screen.